This module will present the principles of image formation with rotational panoramic imaging. At the end of the presentation, you should be able to describe the general design of a panoramic X-ray unit, including the arrangement and function of the components. Importantly, you should understand the principles of rotational panoramic radiography and the formation of the image layer or the focal trough. The content in this presentation has been sourced from Chapter 9 of the textbook that I co-edited with Dr. Lam. This graphic demonstrates the general scheme of making a panoramic radiograph. An X-ray source and receptor rotate around the patient's head. The X-rays are collimated into a narrow vertical beam at the source and again at the receptor. The receptor moves past the collimator during the exposure cycle, acquiring sequential vertical images of the patient's jaws. When viewing a panoramic radiograph, you will recognize that superimpositions from the contralateral side of the jaw are not readily apparent. A key concept in panoramic imaging is the formation of the image layer or focal trough. By moving the source and the receptor, we generate a zone of image sharpness. This zone is referred to as the image layer or focal trough. Objects that are located within this image layer cast sharp images. The closer an anatomic structure is located to the center of the layer, the more clearly it is imaged on the panoramic radiograph. To understand the principles of panoramic imaging, let's consider the illustration of a rotating disc. In this setup, X-rays are collimated at the source and immediately before they strike the receptor. Objects on the disc are imaged as they rotate past the collimator. The receptor also moves linearly past the collimator during the exposure cycle. First, let's consider the situation where the receptor moves past the collimator at the same speed as objects A, B, and C move through the beam. Images of objects A, B, and C will be recorded when they are closest to the receptor. Note that in these positions, structures D, E, and F, which are located on the opposite side of the disk, will be superimposed over the images of structures A, B, and C. Now let's consider the geometry for the image projections for these structures. When structures A, B, and C are being imaged, the source object distance is long and the object receptor distance is short. With this geometry, image magnification and unsharpness are minimized, and thus structures A, B, and C will cast sharp images. In contrast, note that when structures D, E, and F pass through the beam, the source object distance is short and the object receptor distance is long. This makes the images of structures D, E, and F magnified and markedly unsharp. So principle number 1 of panoramic imaging: structures closer to the receptor cast sharp images, whereas structures closer to the source cast magnified and blurred images. Now let's take a closer look of image formation as structures move past the beam. In the presented scenario, the receptor moves past the collimator at the same speed as objects located on the outer edge of the disk. Now let's consider an object located on the outer edge of the disk, represented here by the circle. Due to the coordinated movement of the disk and the receptor, the image of the circle is cast on the same location on the receptor through the exposure cycle. Next, let's consider a structure that is located away from the outer edge of the disk, represented here by a triangle. Note that the image of the triangle is not cast on the same location on the receptor through the exposure cycle, and thus appears as a blurred horizontal streak. Next, let's consider the structures D, E, and F located on the opposite side of the disk and represented here by a square. Note that these structures are imaged in the opposite direction and that their images are markedly magnified and blurred. A key element of the image layer formation is the speed of the receptor relative to the objects that are being imaged. When the receptor is moved at the same speed as structures A, B, and C move past the collimator, the length of the registered image allows the structures A, B, and C to be represented with minimal horizontal distortion. In contrast, note that the same length of the registered image represents structures X, Y, and Z with marked horizontal distortion. Next, let's modulate the system and reduce the receptor speed. Note that the length of the registered image is shorter, and in this case will more accurately represent the horizontal dimensions of structures X, Y, and Z. The images of structures A, B, and C are also recorded on this shorter length and thus are horizontally distorted and unsharp. So principle number 2 of panoramic imaging, the image layer can be changed by varying the speed of the receptor relative to the beam. This holds true for film and storage phosphoreceptors where there is a physical movement of the receptor past the collimator. In CCD-based panoramic machines, a linear array of detectors is affixed behind the collimator and does not move during the exposure. In these units, changes in the receptor speed are simulated by varying the rate of sampling of the CCD receptor. So to accomplish panoramic imaging, we image the object with a collimated beam. Structures that are within the image layer will cast sharp images, and we can change the location of the image layer by varying the speed of the receptor relative to the beam. Note that the same objectives can be achieved by rotating the X-ray source and receptor around the stationary object. Next, let's apply these principles to imaging the jaws. Note that the single center of rotation does not create an image layer that matches the curved shape of the jaws. Early designs of panoramic machines used two centers of rotation. The first imaging arc encompassed the condyle through the canine of the contralateral side. The rotation center would then shift laterally with re-imaging of the anterior sextant and the contralateral jaw. Modern panoramic machines shape the image layer using moving centers of rotation and by varying the relative receptor speed through the exposure cycle. Many manufacturers offer options for different image layers to accommodate jaws of varying shapes and sizes. To facilitate patient positioning into the image layer, panoramic machines are equipped with laser lights that guide patient positioning. You may refer to these resources for more information on this topic.